Madam Chair, esteemed colleagues, media team, I greet you all. Thank you for having me. I don't take this opportunity for granted. I'm deeply humbled by this stage. So my name is Lindoguhle Mdleje, as I was introduced by Madam Chair. So I will be just taking you through our journey in the past 5 years, what we'll be doing as Innobiz Group. So, yeah, I think our outline is summarized as follow. I'll be just sharing with you in terms of who we are, our identity, social impact, skill set capacity, platform architecture, what innovation are we working on, and then why we are here today, why Nikki's CHPC services. And then we'll be sharing some of our, I would say, achievements and challenges that we have experiencing with the platform. And then lastly, we'll be just sharing with the opportunities, integrating, I would say, your cloud services and your agricultural value chain. Okay, so this is our, I would say, summary. Innobiz Group is a startup company that is inspired by innovation through science and technology. So on our side, we are trying to incorporate, as you see our name, it's InnoBiz, innovation in businesses. What we know is science, nothing else. So we wanted to just come up in terms of how we can use our critical minds, science, innovations in terms of making a profitable and sustainable business. Okay, so as we are on the drive of developing a mobile application, so that provides farmers with an instant soil health prediction and addressing the demand of data, soil up-to-date soil data. So our primary objectives is to create an affordable decision support tool that will assist farmers, especially the small-scale farmers, because with the current traditional and conventional methods of doing the soil analysis, majority of them, they cannot afford those services. So as we just said, in terms of how can we come up with an affordable and cheap tool that it can help them in terms of building their businesses. So yeah, why today? So yeah, we will be just sharing our journey in terms of how we'll be using the CHPC Nikki's cloud infrastructure. And then yeah, our objectives, like what we've been doing on the Sibua, it's been on the processing and the storage of agricultural soil images and climate data set. Okay, our dream, I think this idea was conceived in 1st of April, year 2020. So there we were in the middle of COVID-19. So I was sitting, I was visiting my brother. He is a farm worker. So that time on their production, their crop was highly hit by so many diseases. So when I'm engaging them with my limited background from, I would say, material science, I was trying to understand in terms of, okay, why they didn't foresee this challenge. And then everything that they were telling me about, it was they did not do a soil analysis properly when they started their production. So, and then some of the challenges that they were saying, that I asked them why you didn't do your soil analysis. They said those services, they are not affordable for them. So that time, laboratories, they were closed. So they couldn't maybe send even the samples that by then to the laboratories just to understand what is wrong with their soil. So at that time, I was sitting down and then calling my friends and then sharing this idea that here is the burning issue in the agricultural sector. How can we help with our scientific skills and knowledge? So yeah, we came up looking in all, I would say, the tools that we have. And then we came to conclusion that smartphone is an abundant resource each and every community. Poor, rich, urban, rural, and township. So each and every household, they own a smartphone. So we just came up with this idea, apart from using a smartphone for your social media, your Facebook, your phone calls, how can we use it as a scientific tool? Okay. So yeah, that's the dream that we have. I think we are still on the progress. And then, yeah, so here I was just taking you in terms of that on our side, we were dreaming of the smart village in terms of how can we come up with an app that can be used by our farmers in terms of increasing their agricultural production. So in our dream, we understood that alone, we cannot go far. We need to assemble a team, a strong, solid, formidable team that is that would like to take this challenge and then this journey to the next level. So, because we understand that alone we cannot do everything. So we started a journey in terms of how can we assemble this team. And then another thing here, we were also seizing on the international grants because we know that I would say the research, it needs money to run the operations. So we, as a startup, black-owned startup with limited resources, no resources, we understood that for now, before we take this journey, we need to do a resource mobilization. So our mobilization strategy, we formed an international consortium. So as I've shared here, we've got Adiso, Pickup, they are based in Turkey. So Adiso, they are world-class IT solutions, including ML training and AI prediction, expertise in the development of ML and artificial intelligence algorithms. And then we've got Pickup with their vast experience in the cloud computing services and infrastructure. So these two entities, they are based in Turkey. Then we've got the James Hutton Limited and James Hutton Institute. They are based in Scotland. So they have an expertise in the soil image analysis, API development, and spatial data. Then it's us as a consortium leader, InnoBiz, highly skilled in coordinating diverse and multi-country expert teams, exceptional talent in the digital image processing and algorithm development. As we said, that our technology is based on the image-based soil analysis. And then with our local partners, we've got the ARC that they've been providing us with their soil and climate data set. And then we are incubated under Taxnovation, so through, I would say, their business development services. Okay, so our platform architect, as I said, that we are developing a soil testing image-based. So what we are doing, you've got your front end there. So what you'll be doing in terms of taking your image, you'll just create a soil bed. So it's something that must take you about 30 seconds. You just create your soil bed, you make it flat at the top so that you can be able to take a good image. So once you are taking your image via your smartphone, the image will be quickly transferred to the cloud server. So there it's going to be processed. The algorithm that we've developed, it's speaking to your color correction, image correction, and noise correction. So that's why we are saying that we developed a standard operating procedure in terms of how do you take your image. You need to follow a certain rule so that your image can be clearly and also be readable. So in this platform, we'll be storing our soil image data set. We'll be also storing our climatic data. So we are still building our journey. It's start focusing on building an image database. So, and then after all that processing, it will give the recommendations to the farmer in terms of what crop you can plant on your field, how much fertilizer you can get. But that one, it speaks to your scientific parameters, like because our algorithm will be measuring your soil pH, will be measuring your soil texture, will be measuring your soil moisture. So we understand that that information a lame farmer cannot understand. That's why we are coming up with recommendations that will be able our farmer to read when it comes to crop recommendation, crop recommendation, and how much fertilizer they can add. Okay, why Nikki? Nikki's HPC. So we've been privileged in terms of getting an access to Sibua. So Nikki's, they've been, I would say, generous to us. They've offered us these services for 12 months as they understand the challenges of the startup companies, since we are operating with the limited resources, but we need a server host. So our experience with Sibua, it's been good in terms of providing scalable, compatible, and secured cloud infrastructure. Sorry, guys. Yes, I can see it here.
Slide it on now, 7. Just gonna close it and reopen it.
Okay, thank you so much. As I was sharing our experience with Sibua OpenStack Cloud Services, yeah, as they are providing scalable, compatible, and secured cloud infrastructure. So with our Python-based software integrates smoothly with the cloud resources. So the storage handling of our soil and climatic data sets is seamless. So currently, but we've been only storing the soil images only, and then we'll incorporate with the climate data sets later on. So this infrastructure has been accelerating the development, testing, and the deployment of our processes of the project. So the OpenStack has been a flexible tool, and then in terms of efficient crop recommendation and optimizing agricultural techniques through data analytics. Sorry, technical director. Okay, good question. On our side, maybe it's another discussion we can take it even out of this platform. But our experience so far, we were looking for a local host. So in terms of, I would say, the local server, Nikki's, it's our own platform. We've looked at the Amazon, but yeah, just that on my side, I'm not the one who was working on the server because mine is on championing the vision and coordinating the project. But we've got a dedicated developers that are working on the platform. But I would say one of the key things that we were why Nikki's, it's like they are a local, they are a local host. Okay. Okay, so I think I was done. Okay, no, I think I was done with this one in terms of. So coming to our challenges, I would say a major challenge. It was the space. As you can see, there I highlighted on the volume storage with our library data sets, our images, all the models that we've deployed on the server. It consumed about 150 gigabytes out of 200 gigabytes. So as we're still understanding that it's still a prototype, we need more space. So, and then recently, our partners in Turkey, they've managed to download South African GIS data sets. So they wanted to share with us, I think it's about one terabyte. So with that 1 terabyte, with the current storage we have on the cloud services, we could see that we cannot store it. So I think one of the challenges that we've highlighted, it was the storage. So, and then another issue, it was still touching on the storage, it was the backup. That in this, it's very difficult to download and then backup data because of insufficient storage. So some of the things you need to delete them, and then so that you will be able to open a space for another data set. So I think, yeah, it's been a major challenge on our side, on the space side. So we are trying in terms of, I would say, sourcing the funds, making sure even we'll also engage the Nikki's management in terms of exploring how can we increase the space we can look in terms of the opportunities there. So coming to an end, so here, as we highlighted our dream in terms of leveraging on the smartphone penetration in our society. So one of the major challenges that we've identified for small-scale farmers, it was the lack of access to finances. It was lack of soil information and management skills, where you are talking about your technical skills of your farm management. It was your climate variability and changes. As we know that especially we've been hit by so many, I would say, natural disasters. So as a farmer, it's important to understand your future climate conditions so that before you plant, at least you can try to mitigate for other operations. As we know that most of, I would say, your vegetable growers, they are planting under cover. So as a result of these disasters, so the last one, it was the lack of participation to the mainstream economy. So our growers, they are struggling to get the market. So as InnoBees, we took a challenge of how can we come up with a technology that can solve your soil information and management skills. How can we come up with a technology that will be doing your climate predictions for future conditions? So that took us to come up with a traceable and actionable data-driven strategy. So here I will be just sharing our proof of concept, our prototype in terms of how does it function. So we've created a very short video, so I will be just taking you through in terms of how does it work. Okay, as I said there, you go to your camera, you select your image, and you follow the rules, and then we develop an algorithm, and then it's gonna, you get your information about your color palette, your color space, your soil texture, your soil pH. Yeah, color space, soil texture, and then, so this information we understand that, because I said that this project is still on the development, is still on progress. We understand that this information, it says nothing to a lame farmer. A lame farmer wants to understand what I must grow in the soil, how much fertilizer I can add, what irrigation schedule I need to follow when I'm planting. So we are still developing it so that it can give that recommendation that can be understood by the farmer in terms of what type of the soil is that one, loamy, sandy, clay, or what, and then what nutrients are insufficient into that soil. So yeah, so far this is our progress of this project. And then, okay, then coming to an end, I would like to thank my colleagues, Dr. Gustav Patachari and Mr. Nyukayen Maluleka. So we all wanted to be on this conference, but due to limited spaces, they just sent me as a representative of the organization. So we'd also like to thank Nikki CHPC for this platform. As I articulated earlier on, that we don't take it light. We are very humble about this opportunity. Thank you so much.